Welcome everyone. Good evening everyone to this SANS at Mic presentation by yours truly. So hope everyone has been enjoying their day today, as far as enjoying a day or a work day can happen, if you will. Not sure where you guys are located. Again, me, same old thing. Especially these days, I'm in Brussels or in Belgium. I'm close to Brussels, and I'm here for the foreseeable future, given the way the world looks at the moment. So thanks a lot for joining us tonight. We have about 1 hour of content today to share. You'll see that I have about 52 slides, give or take, so quite some slide work to get through. And I also have quite some demos lined up near the end as well. Just one small note, as opposed to normal webcasts, in this sense at my presentation, we'll also be having evaluations just to get some of your feedback on how you're liking the talks. I guess that's going to be posted here in the chat window. So feel free to have a look at them. Don't complete them just yet, of course, because you don't know what I'm going to talk about. Well, you can of course assume that it's going to be great, but I usually start off with a small joke. So let me think. I had one lined up, which was I actually used to play in a music band. We were called 1023 MB, but too bad we never made it to a gig. So there you go. There's your joke. So what are we going to be talking about today? First, as usual, I can actually use this slide all the time. I think I've shown it probably 100 of times. I'm Erik Van Buggenhout. I'm an author and instructor for SANS. I look mostly after the purple team curriculum, which includes SEC 599 and the brand new SEC 699. This is actually pretty much an extract of a lot of the stuff that we're covering in 699, which is purple team, but it's part of the pentest curriculum, which means that we do focus a lot on offensive techniques and we go quite deep into them. We describe how they work. But of course, we put a pretty big focus as well on how to potentially detect these techniques. Next to my work at SANS, of course, I work as a consultant at Enviso, which is a European cybersecurity firm. So I'm very much also someone who still does the work himself, and that's also what I enjoy doing. These days, I've been drawn into a whole bunch of other topics on project planning, given the whole COVID situation, which is, well, it's part of the job, I'll put it that way. But what are we going to talk about today? Persistence. So we want to talk a bit more about what is persistence, and well, not persistence as a basis, because you all know what persistence is all about, right? When an adversary gets access to an environment, to a system, let's say, one of the key goals is going to be to obtain persistence onto that environment. The reason for that is because we want to make sure that we stay on the environment if there would be a reboot or if our current session gets broken. That's of course the goal. So we want to find a way to persist on the system. Now, any of the slides, by the way, and because I have my eye on the questions, all of the slides will be available. Also, this recording is available if you've, of course, registered for this session. So once we have persistence, any other questions, by the way, I'll answer them at the end of the webcast. The goal, of course, is to stay on the system, and there are many ways that we can do this. If you would want to talk exhaustively about, hey, what are the different persistence mechanisms, I would need to be talking for about 1 week, which might be a little bit overkill. What I'm going to try talking about today are some of the more advanced techniques, which are typically also a bit more stealth in an organization. Because one of the things that I've noticed over the past few years when doing penetration testing, but also when working as a blue teamer, because I've been doing quite a bit of both, is that you've got your usual stuff, like I'll install a Windows service, or I'll drop my my executable in the startup folder. I'll install a scheduled task. Even WMI these days, quite often it is not that hard to detect. Now, to be fair, that doesn't make them any less effective or scary, because those techniques are still very, very valuable. And I still believe that they can be very useful in a penetration test / a real adversary emulation red team engagement. But there's a few more where I think it can be a bit more insidious to detect, and they can often be a bit easier to leverage as an attacker. And that's the ones that I want to focus on today. So I've added them here on the slide. I want to talk about COM object hijacking. AppCert DLLs, AppInit DLLs, and Netsh helper DLLs. Now those three are very much linked together, or they're very similar. That's why I put them in one small group. I want to spend some time on Office application startup persistence as well, because that's one of the things where I started looking into pretty recently only, and I was pretty amazed by the opportunities there. And finally, application shimming is also a pretty nice one to have a chat about. So let's get started, right? Let's dive into this immediately. So what is COM object hijacking? We first, of course, have to understand what COM is all about, the component object model. It's basically a way that Microsoft, it's of course a Microsoft technique or a Microsoft strategy. This is something that we can use on Microsoft systems. COM is basically used to allow different applications or different well, let's say software components to allow them to interact with one another. They can do that by using what we call a COM object, which is referenced by a unique identifier called a CLS ID. So how you need to see this is this CLS ID is a certain identifier which is stored in the registry, and in that registry location you'll find information about a specific module that it points to. That's typically a DLL. So what you'll see is that those entries are stored in the registry, and they point to a certain DLL that can then be loaded by the application who is trying to resolve the COM object by trying to resolve the CLS ID. Now, what's important to note is that you have these entries both at regular user level, so in the HKCU registry hive, if you will, and the HKLM, the HK local machine registry hive. So you have two options there. And that's, I'll get to the reason why that's important in a second, but that's pretty interesting. Now note that there are hundreds of COM objects in use. On a standard Windows system, you'll see there's a whole ton of them. If you just look around on your machine, and I'll show you in a couple of screenshots what that actually looks like. There's going to be a whole bunch of COM objects and a lot of opportunity for COM object hijacking, and that is by design. So by design, there are plenty of ways that this can be achieved and can be abused. Now, there's two main techniques here, but there are some others as well. The two big ones are phantom COM objects and COM search order hijacking, which is relatively similar to DLL search order hijacking. So what we'll try to do is trick the application into loading a DLL, for example, by tricking it into loading another COM object instead of the one that it was originally looking for. Now, the very nasty thing about COM object hijacking is that this can usually be performed with regular user privileges. So you don't need, for example, local admin rights, which is a nice benefit for an attacker. So let's talk a bit more about this technique and why it works, because this was just the introduction. Let's walk through this step by step. So here on the next slide, what we can see is that on the left-hand side, we can see that there is a CLS ID in the registry. So you can see the registry location there. And you can see that it points to a certain DLL called C Windows System32 Quick Actions PS.dll. Now, this is on one of my lab machines that's available. If you go and have a look, you'll see that DLL is actually not there. This is a very simple example of a phantom COM object that you could leverage because the DLL doesn't exist. If we could write it there, that would be fairly simple for us, of course, to get our DLL to be loaded by applications who are using that specific COM object, that specific CLS ID. Now, there's a very interesting blog post by the guys over at Cyberbit, I think so. I'll put it in the chat in just a second, which have done some analysis of typical COM objects used by different applications in Windows. And there's really hundreds of them that they listed, and most of them provide opportunities for COM object hijacking strategies. Now, of course, this one, a phantom COM object, it's a bit of a sign of bad hygiene, if you will, and it's basically a misconfiguration. That doesn't mean that it cannot just appear because you've been installing, removing applications. Heck, even a predefined system or a clean system can have these type of issues, but it's a pretty simple one, right? You're missing the DLL, which is referenced. It's not there, so if we can put it there, then of course we can persist. So I drop my DLL as an adversary, and when a valid application, which you can see here in the middle of the slide, resolves the CLS ID in the registry, it receives a path, it tries to load that path, and it of course picks up on the DLL that I put there. That makes a lot of sense. Nothing too crazy there. Now, the next step in COM search order hijacking, this is a different strategy. And this is also a little bit more interesting, because what we're going to do here is we're going to rely on the fact that we have those HKCU and HKLM registry hives. So the current user is of course user level, and the HKLM is of course local machine. That's the local machine level. Now we can see that we have both of them here. What's important to note though is, as a normal user, we can adapt, of course, the HKCU, right? It is within our privileges because it's the HKCU, it's current user. HKLM though, the local machine, is only accessible or can only be edited by local administrators. Now, you might think, and that's a very common reasoning, that the HKLM takes precedence above HKCU, right? Because HKLM is more important. And well, HKLM is managed by the administrator, right? So that would mean that it's more important, so that one takes precedence over the HKCU. Now, imagine that a CLS ID exists both in HKCU and in HKLM. The one that is listed in HKCU will take precedence over HKLM. And you might say, Erik, why? why did Microsoft implement it that way? Well, it makes a lot of sense because this allows for custom or user customization. So users can have different preferences, if you will. They can have different CLS IDs, so they can adapt the normal resolution of a CLS ID based upon their own registry hives. So that's why HKCU takes over or takes precedence over HKLM. That also means, of course, that as a normal user, you can create a CLS ID in HKCU if it doesn't exist yet. And you can basically copy paste the one from HKLM, but you can change the DLL path, for example, point it to a DLL that you would like to load, and that would work perfectly fine. Very interesting, right? This is also one of the ways of trying to detect this, would be to look for HKCU COM object entries, because most applications, when they install, they will create CLS ID entries in HKLM, not in HKCU. But still, this is relatively a stealth technique because it's rather tricky to do. Now, imagine that we would do this as we discussed. That would be what it looks like. So we create, as in on the previous slide, we create the HKCU entry, which now points to another DLL, so no longer the original DLL. And you can see it's a very similar attack path happening here, where I first drop my DLL, I create the right entries in the registry in HKCU. Then, of course, my application or the application that I'm targeting tries to load the CLS ID. It retrieves the path, but the path is now coming from HKCU because, as we indicate, it takes precedence over HKLM, and it, of course, loads my malicious DLL. Now, again, opportunities for COM object hijacking, so applications that you could target, there are plenty of them, and typically you have applications which are well, relatively benign on a system like browsers. Chrome Explorer.exe even is typically a good target for COM object hijacking. So there's a whole ton of these. Now, the thing though, as someone might have already guessed, if you are loading a different DLL, you might be breaking that application that you're targeting, right? That application that you're leveraging for persistence. It might require some functionality that was in the DLL that you had in HKLM, right? The one that was referenced by HKLM. But now you've basically overwritten that and you're pointing towards that DLL, which is referred to by HKCU. So maybe you're now breaking the application flow, and that's not something you want because you are relying on that application for persistence. So you probably want to make sure that it runs in a stable fashion. No worries there though, because a security researcher called Leo Lubeck, he actually wrote a very nice POC, COMPROXY. Now this open source project on GitHub, I referenced it here on the slide. What it basically does is it allows you to create a DLL which can execute or can load, if you will, can execute a specific malicious function that you would like to. For example, you can run something malicious, like even a PowerShell command, as you'll see in the next slide. But at the same time, it will proxy through all functionality to the original DLL. So it will make sure that the original one that was referenced by HKLM is still being used, so that the application that is relying on functions that were in the DLL, for example, that was referenced in HKLM, still works. So it prevents the application from breaking. Sometimes a bit of tinkering around, but it's a nice way of making sure that everything runs smoothly. So if you would like to use a COMPROXY, just as an FYI, you can go and grab it from GitHub, and then you can adapt the DLL main.cpp, where you can actually adapt, for example, here, the system call, and you can specify your own own entry, if you will, your own executable that you would like to run. So fairly straightforward, but this is a nice way of making sure that that the original application or the application that you're targeting for persistence, that it doesn't break upon, well, deploying your mechanism, because you want to stay away from breaking things, because it kind of lures the admins and it makes sure that people will start looking at it, and it's usually no good. Now, this is then the example where we see that, for example, we've put in place our DLL here. We have called it aptly sec699 d4 hijack.dll, and you can see that it's being loaded by explorer.exe. Now, this is a very specific one that we used on our system. So we managed to hijack. I'm not going to read out that identifier because it's a bit of a it's a long GUID, but that's an identifier used or leveraged by explore.exe, and we're just overwriting one in HKCU. We're actually creating an entry which wasn't there. It takes precedence above HKLM, and there we go. Et voila, we can see our hijack that's being loaded by explore.exe. So this is a pretty straightforward technique, if you will. It's actually not that hard when you think about it, how this works. And then we went a bit further, and we used our comproxy to then spawn PowerShell. And then, of course, you can see that and here it gets really ugly. You can see multiple PowerShells being spawned. Why? Because that COM object is actually used multiple times by Explorer. So that's why you get this pretty crazy process tree, if you will. So you have to be careful with this COM object hijacking, because before you know it, you might be shooting shells all over the place, which can be the pen tester's dream. But still, from a stealth perspective, you might want to be a little bit careful with that. Now, COM object hijacking, I often call it the underrated vulnerability, or quite often the overlooked one, because it's there by design. There's no patch for this. There's on any given Windows system, you are bound to find opportunities for this. And the best part, of course, is you don't need local admin rights, because you can just overwrite an HKCU one. So you can overwrite an HKLM entry by, well, not overwriting the HKLM entry itself, but just by creating a similar one, the same one basically in HKCU, and pointing it towards another DLL, a malicious DLL, if you will. So that's pretty nice. Now, from a detection perspective, that's of course the key. Look for CLS IDs which exist both in HKCU and HKLM, right? If you can find those, that's something you want to analyze, because why would there be an CLS ID that's both in HKCU and HKLM? There are a couple of potential normal use cases, for example, user customization, but quite often it reveals that something weird is happening. Now, unfortunately, that kind of analysis is a bit of manual work, because there are no, as far as I know, there's no commercial tools which can just alert upon that to immediately spot, oh, there's a CLS ID both in HKCU and HKLM. You need to investigate which one is which. Now, of course, you can always try to detect that malicious payload, right? The .dll that you drop somewhere on the system, but still, this is pretty tricky, and it can be pretty annoying to spot this when you're dealing with an adversary who's using payloads that are not just detected by an AV engine. There's no auto runs, for example, that will immediately highlight this. So this is a pretty tricky one. I'm going to move a step further. I'm going to walk through quite a few, so I need to keep up the pace a little bit. If you have any questions, do shout them. I can still see that you're asking a few more questions, but you've now disappeared under my bar, so I'll get to them at the end of the presentation. We'll have quite some time left for Q&A. So let's have a look at a couple of other ones, a couple of other strategies that can be useful, but thank God, a bit easier to detect. The first one is AppCert DLLs. What's an AppCert DLL? Now, these are DLLs which are used once you, configure them. So once you list certain DLLs as AppCert DLLs, which is something you can do in the registry, these DLLs will be loaded into every process that calls some interesting API functions, such as create process as a user, create process with login, create process with token, or winexec. Now, that's a whole ton of functions, and a lot of applications use that. So that means that if you can put your DLL as an AppCert DLL, if you can register it there, it's going to be spawned by a whole bunch of applications on the Windows system. So if you use that, for example, here we can see that we can see on our HKLM system, current control set, control session manager, AppCert DLLs, a very specific registry key, which of course allows for reasonably easy detection, if you will, because you can look for manipulation to that those registry keys. It also requires local admin rights because we're dealing with HKLM here, of course. So what we're doing here is we're again dumping a DLL file, so 6699.dll. We're putting that in the right location, so in our AppCert DLLs registry location. And then when we start here on the slideshow, you can just see that we're launching a Firefox shortcut on the desktop, and you can see that they immediately pops open a pop-up saying this is an AppCert DLL proof of concept, which is basically caused by our 6699.dll. So you can see that this is just Firefox launching, which uses the API calls that we've seen before, so the ones that were on the previous slide. I'm just going back here for a second. And then, of course, what that means is that our DLL is being loaded, which allows us to execute our code, which is pretty nice. AppInit DLLs are very similar. So AppInit DLLs can be used, which will then allow that DLL to be loaded by user32.dll into every single process that loads user32.dll. Now, very similar to AppCert DLLs, you can already imagine that user32.dll is quite often used, right? It's a core, it's a very common library to say the least. It's a core part of your Windows environment. So this one again leads to a whole ton of potential persistence strategies that can work very effectively. Note that AppInit DLLs were disabled in Windows 8 and later versions, so Windows 10, when you enable secure boot. Note that AppInit DLLs can also be stopped by exploit guard. So if you well, depending on what configuration you're using exploit guard, you can stop this persistence mechanism from working. So what does that look like? Very similar here as well. We can see that we have a couple of registry keys. We have the 32 and 64-bit versions here. We can see that we have HKLM, software, Microsoft Windows NT, current version Windows, and the WOW6432 node, where we can specify, again, AppInit DLL, load AppInit DLL. You can see that we have those registry keys to enable the behavior for one, and then, of course, a listing in the AppInit DLLs. We have all the different DLLs just in a sequence, in a series, if you will. What we're doing here is we're just specifying our C Windows System 32 699.dll. We're putting that there, and we're getting that one to run, if you will. So pretty straightforward. Now, these are probably the simplest ones that I'll discuss, but just note also that if you're doing that as an adversary or as a red teamer, this is pretty obvious because you have a very specific location where this can be looked for, right? You know specifically what registry key needs to be adapted. So this is a lot less stealthy than the COM object hijacking that we've discussed on just before. Now, moving forward to NetSH helper DLLs. So NetShell or NetSH is the Windows command line tool to manage network interfaces. Well, a bit more, but mostly to manage network interfaces. I don't usually use it that often because in Microsoft, I usually use a lot of different GUIs to get my stuff done. But still, NetShell can be useful when you want to do stuff on the command line. Now, NetShell allows the loading of external DLLs, and they can be registered as what we call NetShell helper DLLs. Now, these are DLLs that do need a specific item. They need to have the init helper DLL entry point. So they need to be specifically compiled to be able to be used in such a way. Once you have that though, you can register DLLs, and whenever NetSH is started, and that can be because of a script, because someone is just running NetSH manually, then that DLL will be loaded as well. Now, the guys from Outflank NL, which is a Dutch cybersecurity firm, they basically wrote a small GitHub page or a GitHub project, which is called NetSH Helper Beacon, which implements the right structure, if you will, or the right skeleton for a NetSH helper DLL that you can easily adapt to then get your payload to execute whenever it's being deployed. So what does that look like? So here we have NetSH. I'm opening NetSH, and I'm just adding add helper C /NetSH helper beacon.dll. It just provides me with a small OK to acknowledge that it was installed. This requires local admin rights again, but then you can see here it pops open calc. Now this is calc, it's just a standard that's done by the NetSH helper beacon DLL, so the one from Outflank NL. They just pop open calc windows, but it gives you a nice example of that DLL being persisted. When I now exit NetSH and I open it again, it keeps on popping up that calc. Now, of course, in a real attack, You probably want to do something a bit less obvious than popping up a calc, but this is a nice way to just show you the proof of concept that it works. Do note, and that's a small remark here, we call this a persistence mechanism, but NetSH doesn't start on boot. So you might want to, there's a few options there. You might want to use another persistence mechanism that actually launches NetSH to make it, well, you could do that, right? You could actually put your DLL as a NetSH helper, and then you just point another persistence mechanism, something a bit more obvious, like a service that actually launches NetSH. Maybe that's not that weird in the target organization, because NetSH is a Windows built-in tool, right? Why would it be bad? So that's just something to think of. Could be useful. Now, the bad news for attackers and the good news for defenders is that, again, this one, as with most of these DLLs that we've talked about, they do need to be deployed in very specific locations. So we already mentioned the different load AppInit and the AppCert ones. There's also some LSA authentication packages that you can add, but more on that later. But same thing always, they need to be deployed or they need to be persisted in very specific registry locations. So that allows you to rather easily script that and to fetch that information, to look for it, to assess your environment, to baseline, if you will. So here we can see, for example, that NetSH helper beacon has been registered in the HKLM software, Microsoft NetSH. So you can see that that DLL is there next to some others. Now, if you have one system where you see that there's suddenly a DLL which has, first of all, an absolute path, and also one that you don't really, that looks a bit weird, that's probably something you want to zoom into. So there are, for most of these, there's quite some opportunities for detection, and that is also confirmed, if you will, by some of the public Sigma rules which are available in the Florian Roth's repository. Now, Florian Roth maintains the repository, but he didn't develop all of the rules. But here we can see, for example, one rule which is going to look for netsh.exe being used to add the helper. So you just very simply see that it's looking for process creation events, looking for netsh, and looking for add and helper, which is a pretty nice way of doing it. But yeah, it's also pretty it's detection of the specific implementation of the netsh helper, which is nice. Now you could also, of course, pivot that around and just use different rules. And here are some other examples. This time they're looking for the AppCert DLLs. Sorry, I was almost confused between AppInit and AppCert DLLs. And we're using event IDs 12 and 13. Now this is Sysmon specific, right? Event ID 12 in Sysmon is key creation. And event ID 13 is the value of a key being set. And we can very easily use this rule to specifically look for the AppCert DLLs. Why? Because we know exactly in what location they need to be put. So we want to look for that. We also want to look for key renames. Because that you could also try to manipulate a key that already exists. So that's why event ID 14 was added there as well. But so you can see again that because you have to manipulate a certain specific registry key, the detection of that is not that hard, and you can actually write pretty solid Sigma rules for this. Same thing here for event ID 12, 13, again for AppInit DLLs. Same thing, just a different registry location. I presume that this is rather straightforward and it makes sense for most people. So I'm going a bit quicker here because I want to get to my demos. The COM object hijacking one, I can tell you that's annoying. It's really hard for a defender to spot because you have to do a comparison. Now, all of these DLLs that we've just discussed, usually they're pretty okay from a detection perspective because they require specific registry locations to be manipulated to be stored. Right, so there are some options there for detection, as I've just shown. Now, Office. This is another one of my favorites because it's rather interesting, and I'm sure there might be some surprises in here, even for some of the more experienced pen testers. Now, first of all, I don't need to introduce Microsoft Office, but I will do it anyhow. It's the premier Office applications tool suite provided by Microsoft. Everyone has Microsoft Office. Now, we mostly touch upon Office when we're discussing VBA macros, right? From a security perspective, because everyone's scared of those macros, and you can get code execution with VBA, and VBA has so many opportunities because it has access to the Win32 APIs, so you can do nasty stuff like allocating memory. You can do process hollowing, all that stuff with VBA macros. Pretty weird things that you can get done. So most people are pretty scared of VBA macros, and that's why a lot of people are hardening those settings very carefully in their organizations. Think of situations where you don't allow macros to execute, or you whitelist macros based upon signatures, for example. All depends, of course, on how you're doing that. But next to that, there are some other options with Office as well that can allow us to persist as attackers. First of all, there are templates that we can use, and there are different add-ins that we can use. So what are add-ins? They allow additional functionality inside Office. Now, I usually, what's a good example of an add-in? Let's say PGP for Outlook. That's most of the time that's usually done by add-in. So when you want to use PGP in Outlook, you want to have some form of doing mail encryption, that could be an option. That would be an example of an add-in. So it's a third-party product that you install inside your Office tool suite. The templates are, of course, Office document templates that you can use as a basis for other documents. A definition of a template, if you will. Now let's have a look at the default template in Microsoft Word. Here we can see in my lab environment that I have a normal.m file, which is a template file. This is default Office template used by, I think this is the latest version of Microsoft Office. It's Office 365 that I'm using. And we can see that is stored in C users username app data roaming Microsoft templates. Now, if you just double click it, that's not going to work because it's actually going to create a new file from that template. What you want to do is change the template itself. So we can right click it and we can open it. When you open it, we can go to the VBA editor, for example. Oh, again, VBA, Erik, you said you were not going to talk about VBA. Well, yes, just very shortly, because we want to show how you can actually use this to get some nasty things done. So yeah, please refer to day 2 materials. As I indicated, this is an extract from the 699 course. This is, I'm not going to walk through all kinds of VBA code. I'm just using a small message box here to show you, look, this code gets executed. So what I'm doing is I'm adding in that document, I'm just adding a small auto open function, and I'm getting that to run, well, when the document opens, and I'm getting a message box to pop up, which says that the macro was executed. This is pretty straightforward. Now we can now save that into the normal.m file, right? And now we can create a new file, right? So I'm just going to create a new file, a new Office document. And this is a normal docx file. So we're just creating a hello student, this is a test, and we call it test.docx. We can save that, for example, on the desktop. And now when you open the test.docx, you'll see that without doing anything, without allowing any kind of macros to be executed, you can see that the macro actually gets executed. Also note that the setting in the Trust Center is the one that we had by default, which is disable all macros with notification. Now, the ugly thing here is because the template is macro enabled, which is by default, then it basically loads that file as part of your test.docx, and there you go, you can see that your macro gets executed. Now, again, with the proper persistence mechanism, if you would want to do that a bit smarter, then you would not have it pop up a message box saying macro executed. You might want to have it do something more interesting, like doing some process hollowing or spawning indeed a proper shell back to your attacker machine, something like that. Many different options exist because you now have VBA code execution. Also note that normal .m file, so the template file, it's user writable because it's inside the user directory. So it's something that you can do there. Can also be very useful when you're dealing with VDI environments, where you have, for example, user profiles which get roamed across the VDI environment. But when you're manipulating the registry, for example, it doesn't do anything. But this could help because this is a very nice way of persisting. It gets better though, because even if you do disable all macros without notification, if you then open your document again, it keeps on hitting that macro executed. So every Office document that you now open basically on that machine will have some pretty ugly VBA execution, if you will. So it's rather persistent, if you catch my drift. It's a rather persistent persistence mechanism. Now you could say, Erik, but why does that work? Why does disable all macros without notification? Why doesn't that block your macro from running? The reason is a different setting in Trust Center. It's basically the trusted locations. If you go into the trusted locations, you'll actually see that user data, the folder that we just mentioned before, where the templates are located, that is by default a trusted location. But it's also a user writable folder, so you have to be very careful with that. But the nice thing is that because it's trusted, the VBA restrictions don't apply. It doesn't matter. It's going to execute them anyhow because it's a trusted location. So this is the default setting in Microsoft Office installations, which is often overlooked, which is pretty nice to do. Of course, this is again, it's a persistence mechanism, right? So you first need to get some form of code execution before you can do that. If you don't have GUI access, because you just have, let's say, a shell or a command line, you could enumerate the trusted locations as well by looking at the registry. They're stored in that specific registry hive. So you can see here HQCU software Microsoft Office 16.0 Word security trusted locations. And then you can see location 0 is the app data Microsoft templates. And you can see the different locations, they're listed one by one. Now, onto those add-ins. So going a step further, as we already mentioned, we can use add-ins to extend the functionality of Microsoft Office applications. Most of the time, these Office add-ins are actually, they're not entirely Windows DLLs, but they're very similar to DLLs. So you can write your own DLL and then compile it. Just one small note that you have to make sure that if you use, for example, a DLL like this one, this is a nice template with the DLL main function where we have a case DLL process attached. That's specifically where you need to put your code to be executed. So what we can do here is we can just create that DLL, compile it, and then we just need to rename it. For Word add-ins, you have to rename them to .wll, and Excel add-ins need to be .xll. Which is, as you could expect, that's how you need to do this. So yeah, you can create your own DLL, compile them, and then adapt them. And then here, for example, we can have a file called evil.xll. I'm just switching gears here and I'm using Excel instead of Word because we used Word for the templates. Let's use Excel now just to show that you can add some ugly stuff here as well. So I'm using evil.xll. As you can see, again, it's dropped inside a user directory because it's an app data roaming Microsoft add-ins. And one thing we do have to, and this is a bit trickier because this allows for detection, but we also have to create a registry key here, which is in HQCU software, Microsoft Office 16.0 Excel options. And there is an open key, which can be there or cannot be there. It depends on your configuration. If it's not there, you have to create it and you have to specify /r evil.xll. This will load the evil.xll. It will use it as an add-in once you launch Excel now. And then if you launch Excel, I'm just giving you a short screenshot here of Excel then loading my DLL. So I'm just opening Excel here. And what you can see here is that you can see that there's a load image. I'm using Process Monitor here to show that my DLL is effectively being loaded by Excel. So you can see that you have this evil.xll. Pretty straightforward. Also note though that if you go to your Excel GUI and you check out the add-ins, this file will pop up. It will tell you. So if you go there, it will actually tell you, look, active application add-ins, C, and then the entire location, evil.xll. What's weird though, and that's something that I saw myself when testing this very recently, even if you disable all application add-ins, with which is a specific setting you can configure in the Trust Center, you can still see that the evil.xll it keeps on going, which is very weird because all of the different application add-ins they're being disabled for some reason. So they're actually disabled. So all of the ones which were actually enabled before, but my evil one stays there. It keeps on keeps on going. So it's it's evergreen. It's die hard. So the evil.xll just keeps on popping up. I think that might be a link to that registry key, but I need to look into that a bit more. But it's interesting that seems to ignore that specific setting, which is good news for attackers. Less good news for defenders, if you will. Gets a little bit worse for defenders because if you use autoruns, which is quite often used by defenders to get some analytics going to spot, for example, persistence mechanisms, it has many different categories. But you can see that if you go to the Office tab, which supposedly lists the persistence mechanisms in Office, we can only see that on this system that I've just infected, there's only a link add-in for Outlook, but that one was already there. So it doesn't even have my Excel there, which is very interesting. So it doesn't list that one. So yeah, that's another nice one. So it's a good way of tricking defenders, if you will. Now, a couple of ideas here for detection. My apologies for the title of the slide. It should be a different one. It's not AppCert persistence. This is, of course, Office products which are spawning typical Windows shells. This was developed by Michael Haag, Florian Roth, and Marcus Nijs. They basically wrote a Sigma rule where they show, look, it's pretty straightforward, but if any of the Office applications launches a typical like CMD, PowerShell, WScript, CScript, Bash these days, WMIC, MSHTA, and so on, that's something that you want to know about, because that probably means that there's some form of code execution originating from one of those files. So it might be something to look into from one of those executables. It's pretty much a catch-all rule, but it can be quite effective. Final one, and then we'll go into some demos because I have 20 minutes left. I'll probably take about 5 more minutes for application shimming, and then we have about 10, 15 minutes, let's say 10 minutes for a demo, and then we still have some time for Q&A. So application shimming, another pretty interesting one. Everything is interesting, right? That's the curse of InfoSec. It's all so interesting, and you can all dive into it and keeps on going, and then you find something else, and there's something else, and you keep on going down all of those rabbit holes. It's just madness. But application shimming is basically used, or it's a mechanism by Microsoft to ensure compatibility with older versions of the OS. So how can we abuse that? Well, application shims allow you to create what we call a database, which can be installed on a Windows system that will tell the Windows system how to adapt the executable when it's running to make sure that it runs on this new version of Windows. That's the concept. That's what an application shim is all about. So how could we abuse this? Well, as an attacker, we can install the application compatibility toolkit, which is these days, it's part of the Windows Assessment and Deployment Kit. That's for Windows 10. That's where you find it. It's a bit tricky to find sometimes. Once you do that, you can create a fix for target applications. Now, this is again something that you typically do on your attacker machine. Now, that target application can, for example, be PuTTY. It can be Outlook. It's an application that you know that the target will have installed as well. So you can create a fix, and you can use a way of fixing the application. Now, what are some of the fixes that are available in the toolkit? There's a whole ton of them. And I'm using here in my step 2, I'm using inject DLL because it's a pretty straightforward one, and it's an easy one to explain, which is going to make sure that the executable will now launch or load a specific DLL when it's loading, right? So you can already guess what could go wrong because I can reference another DLL, a malicious one that I want to load as part of the application, as part of the target application, supposedly to fix it, to make sure that it runs well in Windows 10, for example. But of course, that's not my goal. I just want to add some extra functionality to the application, some extra malicious functionality. And then we can port that shim database, the SDB, basically, we move that over to our target system, and then we can install it on there. That sounds very heavy, but let's have a look at what that looks like. So this is me abusing the application compatibility toolkit. So I install it, and then I can run compatibility administrator. I'm going to use PuTTY here as an example. So I'm going to target PuTTY. So PuTTY, C users, student LADM desktop putty.exe. That's the application that I want to fix. I'm going to ignore the first step, which is compatibility mode. So it's going to ask me, okay, but what do you want to do? How do you want to fix this application? There's no specific mode that you want to use. No, I'm looking for a very specific fix. And the fix that I want to use is inject DLL. Now, in that inject DLL, you have to set a certain parameter, which I'll show in my demo, but you have to specify what DLL you want to load, of course. And then you can get it to load. Now, I use inject DLL here. But there's more, right? There's a whole, the application shimming database is pretty big, and there's a whole bunch of available fixes that you can use in Windows. For example, there's redirect exe to redirect execution. There's some pretty interesting ones to actually stop some of the more modern, or well, what you call modern, depth, right? It's super modern. Some of the exploit mitigation techniques like disable NX, disable real-time Windows Defender for the application, disable ASLR, disable structured exception handling, redirect file system paths, redirect registry paths, all that stuff you can also do. So this can get pretty ugly. I haven't played with all of these before. I just know that these are some other options that you could try using when you're dealing with this, when you're messing around with application shimming. So as I mentioned, I'm just using inject.dll, and I'm again trying to add my C users student LADM desktop evil.dll. I'm adding that in there. I just now specify, and that's the nice part. The final step is you want to specify when the application shim should kick in, and you want to basically give it matching information. Matching information, it's going to provide you with a whole ton of properties that it extracted from putty.exe. For example, the size, the checksum, the file version, the product version, and so on. And you can use the checkboxes here to indicate which ones you want to use to rely on to identify when the fix or when the shim should kick in. Right. Now, obviously, you want to make sure that you've put this correctly so that when you move the database, so the shim database, and install it on your target machine, that actually triggers on the version of the application that's installed on the target as well. So I can specify the database name, it's putty, and then I can just extract it. And then on my target system, for example, I could just do sdbinst.exe. So that's built-in tool in Windows to install this kind of shim caches, and I install my putty.sdb, and it says installation complete. Note that when you see people messing around with these command line tools, that's probably something you want to look into as well. And then if you test it out, you open putty. There we go, very simple. Putty launches as expected, but then once you go into the event properties this is again Protmon in action. If you see putty.exe, you can see that it loads a module called evil.dll. So that's pretty nice. So you can see that effectively you managed to add your evil.dll into putty.exe, which is pretty nice. So again, you've got your persistence mechanism there. Now, how to detect this one? Well, there's a nice rule written by Marcus Nice, which just looks for sdb-inst.exe and .sdb, which is quite often a sign of malicious behavior, because there's not a lot of administrators who are doing this with sdb-inst.exe. So quite often that's something that you can look for. If you see people using that, that's something that you want to trigger upon. Also note that from a detection perspective, this will now, once you install it on a machine, once you install it on a target machine, this will show up in the programs and features list. So once you go into the programs and features, you'll see here, for example, you can see putty. That's actually the name of the SDB database that I installed. There's no publisher information. There's no size, but that's the app compat shim that I installed. So it's pretty obvious that that thing is there. There's also another artifact in the registry. You can also find that back because you have your HKLM software, Microsoft Windows NT, current version, app compat flags, custom, putty.exe. You can see that one exists, which is again pretty good to know. So you know that someone installed an compatibility shim for putty. Now, OSQuery can also fetch these. So OSQuery can find these application shims as well. If you have OSQuery deployed, it's a very simple table that you can use to go and grab them, which is pretty nice. There's also this one, which is interesting. This was actually only shown a couple of years ago, I think 2 years ago. It's a project by, is it Jackson 5? If you literally Google it, you'll find it immediately. It's a GitHub page by, it's not Jackson 5. It's Jackson 5. Yes, it's Jackson 5. On his GitHub page, he has this very nice one. What he's doing here is they're actually leveraging these shim databases, but they do it in memory. So they make sure that their fixes, they don't have to be installed, but they can actually do that using SDB Explorer, which is a tool that allows it to happen in memory, which is pretty nice. So that way you don't leave that many traces. So this was first observed by FireEye, who actually saw that the threat actor Fin7 used this technique to implement their backdoors, to implement those SDB fixes without using SDB install.exe. So that's a pretty nice way of doing things. So let's have a look at the demo. Let me get my system up and running here. Give me 1 second. And I think, do you now see my commando VM?
Yes, I do.
Thanks, Carol. People weren't sure if they were allowed to respond. So let's have a look here. So I've got this commando VM, which is, by the way, I've been testing this for a few months now. Pretty impressed by this. This is the FireEye or the complete managed offensive VM that they're actually pushing. They have actually Kali built in. I've been using it more and more over the last couple of months. It's a pretty nice tool. Because one of the things I always loved about, well, Kali is great, there's no doubt about it, but the one thing that Commando VM just facilitates is a lot of the Windows stuff. A lot of the, like Visual Studio, Unity Compiler, DLL, all the stuff is just a lot easier to just do on your built-in Commando VM. So I've got most of my tools here listed, which is pretty nice. So thumbs up for the FireEye guys, that's pretty impressive work. So where was I? Yes, small demo. So let's have a quick look. The one that I wanted to show was just already to show you the, let me just jump on a target machine here. So this is my attacker machine. I've got the target machine here as well, which is 192.168.40.9. It's a system which is inside the domain that I'm targeting here. Yeah, I have my on-screen keyboard because sometimes my my keyboard goes bonkers when I'm trying to type specific characters. So I'm just going to open RDP session here to that machine. I'm just going to, that's one of my colleagues who's still on that machine, I guess. Might have to kick him off. No worries, I've got multiple machines. The joys of a shared lab environment. Just once. Oh, there we go. It's probably in this webcast. Oh, that's me. So here we've got this, it's just a standard Windows 10 machine. Actually, I'm immediately going to take this opportunity to, there's a question here. I'm just picking it up because it was part of my demo. I'm amazed the .m issue is still a thing. Malicious SCR file next. Yeah, well, it's a good remark, but it still works really well. So if you go in here, for example, this is my C user's default. Sorry, my default user. Let me just take my current user student LADM app data. Go into the roaming Microsoft templates. So here you can see this is just the default .m. Very simple. Just open it up. I haven't touched the system. Not yet. This is just a quick install. You can see it's actually a clean install of Office. I haven't even configured it, so it's just a trial version. And we can just go into the macros, create, blah. I'm just going to get rid of this. I'm just going to go here in this document, and I'll just add something simple. I can just use the same thing that I've used in my slides as well. I'll just create a small auto open, and I'll just do something message box. Hi, Michelle. A small shout out to one of my colleagues who I hope is in the webcast. If he's not, then we'll have to have a chat afterwards. He promised. I'll just save it, save normal. There we go. Close it down. There we go. And then you'll see that let me see. All of these different screens. It's almost Inception. I'll just go into my WinWord. Sign in. Blank document. So you can see nothing happens at the moment. It's because I haven't saved this yet, right? This is just a blank document, but then I can do blah blah, and I'll just save this as a docx file. Very simple. Put it on desktop docx. There it is. Close it down. I'll just open it up now, and then you'll see that. So yeah, the VBA code just executes, which is pretty nice. It's a pretty little, it's a nice little trick, which, well, and you can see that whenever you open this, it just keeps on hitting, of course. Which is it's not groundbreaking, but it's a pretty nice trick that's often forgotten, because where is this actually configured? If you go into the options in Windows, go into the Trust Center, and then you can open up the Trust Center, and here you can see disable macros with notification. As mentioned during my my presentation or my slides, you can also use disable all macros without notification. It's not going to help. The reason for that is because this thing here, this is by default a trusted location. It's your Microsoft templates directory, which is a little bit it's annoying, I know. So that's just one specific one. So that's one small one. Now I do have, if you guys, do I still have time to have a quick look at the application shimming as well, Carol, or do we need to finish at in 4 minutes? Is that a hard stop or?
You have plenty of time as far as I'm concerned.
Okay, that's good. So I'll just have a look at, because the application shimming is also a pretty nice one to give you a small walkthrough on. So I could demo all of them, but that would take us 1 more hour, and it's, well, it's 10:30 here already. I have to work tomorrow. I'm kidding. Everything for you guys. So let's have a look at the application shimming. This VM. So I'm back on my attacker machine. Sorry, just get rid of all of these. No, it's compatibility administrators. Jesus, they like to rename things. So I'll just run this as administrator. So this is the compatibility administrator, as I mentioned, which is part of the Windows assessment and what's the acronym again? It's Windows Assessment and Deployment Kit. So that's where you can get this one, and then you can just very simply you can add a small fix here. So we could say in this database. So a database is a collection of fixes. We can just say, look, let's create a new application fix. I want to fix. Let's just use putty for the sake of the example. Where is it located? I'll just use it here for my desktop. So I prepared. This is just, you can see if I open it, it's just standard putty. Nothing weird about this executable, right? It just opens. I want to target this one. I want to avoid the compatibility modes because I don't care. And then let's have a look at inject DLL. That's the one I want to abuse. Parameters. Let's say that I want to target this towards, that's why I have my on-screen keyboard, because I cannot type the backslash. Evil.dll, which is not there at the moment, so I'll have to put it there, but I'll just add it there. And here we can just say, okay, what's the, how do you want to match the applications that need to use this shim database? And I'll just use what he proposes. So he just gave me a couple of options, which I think look pretty fine. So product name, putty suite, file version 0.73 with embedded help. I guess that's a pretty good match. So we'll just use that. Now it's created, but it's of course not installed yet. So we can save that here, and we could call that, let's give the database name something Windows Update, right? Something very stupid. The reason why I'm using that as a name is because that's actually what's going to pop up in your program, in your application features and software. So I just call this Windows Update.sdb. Now it's not installed yet, so I haven't done anything bad at the moment just yet. What you can do now, however, you can, if you have the GUI open, you can just right click and install it. That's going to install it here locally. So I've now backdoored my own system, if you will. I still have to put my evil.dll there though. So I could just go here and put that one in C. There we go. Yeah, there we go. That should work. But let's immediately do it onto a target machine. I've just backdoored myself now without any good reason. So I'll just copy evil.dll. I'll just copy it over to 192.168.49. I'm just going to copy over the same version of PuTTY. Yeah, my apologies, I don't have PuTTY on this machine, but in the real in a real life example, you would use an application that's already there, right? So you don't have to bring it yourself. Let's also use a Procmon here for a second, so that we can actually see what's going on, so that we can actually see whether my DLL is being loaded. So if you just open this. Oh, the final thing that I need to copy is of course my SDB, because that's the one I want to install. Just put it there as well. Oops, let's clear that here for a second. And let's just get my backdoor in order. I'm just using the GUI here, but of course you can, there's plenty of ways of doing that with the command line as well, right? I'm just putting my evil DLL in the right place. I have to put it, because I'm copying to C. Application shimming obviously requires admin rights. That's something that should be clear. That's going to require admin rights. There we go, evil.dll. Now I still want to install my Windows Update SDB, so I can just use sdb inst.exe, and I'll point towards Windows Update.sdb. There we go, it installs. Again, sdb inst.exe is a built-in tool. We can just launch process monitor here now. Let's launch this guy so we can start monitoring. And very nice. This is some other work. I'm just adding a filter here because if you're familiar with Procmon, it's going to spawn us or it's going to kill us with events. So we'll just add a small filter here, load image. There we go. You can already see that even load image generates a whole ton of events. Let's see when we run putty.exe now if our evil.dll is being loaded. So there we go. And a bit slow. Where did my there we go. Putty evil.dll being loaded. So there you go. The others are of course all just DLLs which are being loaded by Putty by default. So you can see that your evil.dll is being loaded, which is nice. So you can see that that's effectively being added to Putty now. On the detectability of this thing, of course, as we mentioned, it's rather noisy. So if you go to control panel and then have a look at your installed applications, tends to be a little bit noisy. You can see Windows Update here, which looks also a bit weird. So it's like, oh, look, this is an empty Windows Update. So we can just uninstall it, get rid of it. There we go. All right. So that brings us at 10:30. Just to respect everyone's time, let's have a look and let me go back to the slides maybe and just answer your questions. Where did I put the slides? Boom, 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 boom. There we go. So I'll put this here. Just finishing on this. I'm showing my other screen. I'm showing you the presenter view. There we go. So this is the final screen too. Yeah, there you go. Now you see it. So I think that's about it for us. If you have any questions, feel free to drop me a mail. On questions that you had, let me just walk through them here one by one now. So I'm just opening the questions. So there's one question: is there some easy way to check with COM objects will be used by an application frequently used programs, for example, or is the hit and possible miss when you hijack a COM? This is a great question, and I'll immediately share with you the link. The easiest way to do that is actually use Procmon, which I just showed in the demo as well, and look for you can look for two things. Either you can look for registry keys which are being queried, and you can filter for the CLS ID. So you see all of the CLS IDs which are being queried by different applications. So the idea is you test it on your own machine, for example, explore.exe, what does it load? And then the next step is, of course, once you find one, you can build your hijack and then you can run it on your target machine. So that's it's not hit and miss because you can actually prepare it on your own machine pretty well. And a good article is the one from Cyberbit on COM hijacking, which I've just put in the chat here. So that's a very nice example, which makes it very practical. They also discuss how they approach it and how they see it working. So there we go. Other questions? Yeah. So the one on the does SDB Explorer still require admin briefs? I do think it does. Mark Oxenmeyer responded to it, I think. which is very interesting. Don't be okay. That's a remark. What else? AppInit DLLs, typically they're not. I don't think you can use them because there's a question: is there any system process load user32.dll so I can use AppInit to get system privilege? I haven't seen it, so I don't think that's an option. I don't have a question. One more. Oh, one more hour is fine. Why did the macro run even though Word had disabled it? So I'm skipping through the question. Some of you are giving me some nice comments, so thanks for that. Why did the macro run even though Word had disabled it? The macro ran because the template is in a trusted location, and the trusted locations, they ignore your macro restrictions. So that's the problem there. So that Office template thing, it's an old trick, but it's very ugly, and it works pretty well. So that's the reason why that's working. And I think that's all of the questions that I ran through. Now, if there's anything else, because well, you've seen this now, right? So we've discussed the entire deck and the entire presentation. If you have any other questions, feel free to shout to let me know. And if there's anything, then I'm happy to always respond to any other questions. I'm also looking forward to potentially see you at one of our SANS events. Well, if we get to live events again, right? For now, I'll see you at an online event maybe. And of course, you know where to find me. You can always find me at evanbuggenhout@nviz.eu. And thanks for your time. And I wish you a very nice evening. Thanks.